Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have talked about various hybridization, that is sp3, sp2, sp hybridization, and now we are going to do a new topic, that is sp3d hybridization. So we know about that how the recasting and mixing takes place, but now we are going to talk about a new topic, that is the molecules that show sp3 hybridization, and let us talk about that. So what is actually sp3 hybridization? So let us talk about that one. That is the process of mixing and recasting of one s orbital, 3 p orbitals, and 1 d orbital of the same atom with nearly equal energy to form 5 hybrid orbitals having the equivalent energy, maximum symmetry, and definite orientation in space. So that kind of process of mixing this atomic orbitals so as to form a new atomic orbital or hybrid orbitals, we could say. So that kind of processing is known as basically hybridization, and that is what sp3 hybridization is. But talking about again, I will tell you that SPD, they almost, because we know that the energy level is like they are almost the same. Like if S is very much similar to that of the energy of P, and which is very much similar to that of D, but they are not exactly the equal. But whenever they form hybridization, or whenever they form mixing of the atomic orbitals, so they form a new kind of the hybrid orbitals, and those hybrid orbitals have equal energy, and that is what we are talking about, and this is the thing that we have discussed in our previous lecture also. So now let us come back to the point, and let us see that which are the molecules that are being exhibiting the sp3d hybridization, and let's talk about that. So the molecule that is commonly that we are going to talk about in this example is basically formation of PCl5, or we could call it as Phosphorus Pentachloride. So this is the example that we are going to talk about, and let us understand it. And so before going with the hybridization, this is the thing that I want to talk about, that is phosphorus is the one that is present in the central one. So that's the reason it will be the only one that we can show that is hybridization, and let us understand that. But before understanding, let us understand that what would be the structure, and what would be the orientation, or how many bonds it will be formed. So this all are the things that we could know if we write the electronic configuration of phosphorus. So suppose phosphorus 15, which has an electronic configuration that could be written as, that is 1s2, 2s2, 2p6. So this has made is 10 electrons or 10 protons, we could say. And talking about the later one, that is 3s2 and now 3p3. So this is what it has, covering everything, and that is 15 electrons or 50 protons, we could say. And now because this one, that is 3s and 3p, these are present in the outermost shell, and that's the reason this will play a very vital role in the formation of bond. And let's talk about this one. So talking about the atomic orbital, so this is the atomic orbital that is of s orbital, if I'm talking about, and this is the p orbital, or for p subshell there are basically 3 atomic orbitals, and that is what I'm showcasing over here. So now let us fulfill the electrons that it has. Basically for S it has 2 electrons, and for P it is 3 electrons. So therefore individually at Px I would write it over here. For Px it is 1 electron, for Py it is 1 electron filled, and for Pz it is 1 electron that has been here, as you could see. Very easy one. But the thing is, the phosphorus is forming 5 bonds because of PCl5 is present, and obviously phosphorus cannot form bond while having 3 unpaired electrons, as you could see over here. Obviously then what we need is, we need the excitation of electrons in such a manner that we could get 5 unpaired electrons. So in this case basically there is no 5 unpaired electrons that we have got over here. So that's the reason that we have to excite the electrons. We have to excite the electrons such a way that the electrons will shift it towards the nearest empty orbital or empty subshell, if you are talking about in that way. So for that, if I would say that is, if you go in a sequence way, not in a sequence of energy, suppose as like subshells and shell to shell, so that in this case we'll get to know that is 3d0 is the one, that is what we could get. So now here we have got basically 3d0 means an empty orbital that we have, and because of which only we could actually excite the electron. So this is the thing, or this is the electronic configuration that we have made and we have arranged that was in ground state. So let me talk it about like GS, ground state. So the thing that are in main concern that we are going to talk about is basically this outermost shell. So in this outermost shell, suppose the electrons that is to be excited, but let me just mention it in like that of 3s and 3p and like 3D subshells. So talking about the S1 or 3s, it has basically one subshell. I would write it over here like this one, or I'll mention over here. Well, the P is what we know it as it consists of basically 3 orbitals. Talking about the D1, it consists of basically 5 orbitals. 1, 2, 3, 4, and this is the 5th one. But this ground state electron or the ground state electronic configuration that we have mentioned about the phosphorus 15, it doesn't consist of any electron in D subshell or D orbital. But what if we have excited the electron? So suppose this is the electron that is now been coupled with that where we could see in the 3s subshell. So in this case, basically the electron are being present in the coupled way. So what we have to do is we have to excite the electron. So therefore, this coupled electron or this pair of electrons will be now basically unpaired, and that is the reason that one of the electron will be shifted from s orbital to that of not with that of p orbital, because everyone or every electron are present in an unpaired manner. So obviously, this electron will move toward the 3d orbital, and that is this one. Well, the rest of the electrons that will remain the same, and that is what I could mention over here. That is 1, 2, 3, and 4. So in this case, basically, this is the process. What we have did is we have excited the electron, and that's for this state is known as excited state, and this is what we are dealing with, and that is what we have got. Basically, we are now have followed the first step of the hybridization, and that is excitation of electrons, and this is what we have got. That is, we have got basically 5 unpaired electrons, and that would be now be very much responsible so as to form that is 5 bond with that of the chlorine atoms that are going to attach with that of the phosphorus. So the first step is done, and the second step is mixing and recasting. So this is the thing that we are going to do now, and it is a very interesting one. So let us understand that there is one s orbital. I will write it over here as one s orbital. There are 3 p orbitals like px, py, pz, and there is one d orbital, and that is basically I would name it as like dxy, suppose. So now in this case, obviously the mixing of hybrid orbit or the mixing of atomic orbitals will lead to the formation of the hybrid orbitals. So let us mix that. So in this case, basically we will get this is one s orbital. So that is what I have mentioned over here. That is later we'll get combined with that of 3 p orbitals, and ultimately we'll get basically one that is d orbital. So this is px, py, pz, and this is dxy. So this is what we have got after mixing of that is atomic orbitals, and this all will lead us to give basically sp3d hybridization. So this is what we are talking about. So now let me explain that how does it happens with the help of the structure of the shape of the orbitals. So in this case, basically everyone will be involved in the formation of the hybrid orbitals. So like that of S is of spherical shape that we know. That is one s orbital will be involved. That is of spherical shape. Talking about the next one, that is px will be involved. So suppose if this is the orbital that I have mentioned it for px, double shape one. So therefore this is px. One will be py. So suppose if this one is basically I'm talking about py orbital and pz orbital, that is basically mutually perpendicular to both the px and py. So this is pz. And talking about the last one, that is dxy. So in this case, let me give you a short idea that what would be the shape of this one. So suppose if I'm talking about that is the axis is like this one, x-axis, y-axis. So therefore the dxy, it is between, the orbitals would be between that is x and y over here, as you would see. So this is the first one, well this is the another one, that is what I'm trying to say. So this is the thing, but don't go with my diagram, actually it is very so this is the structure that we have got. So now everything is what will happen is they will mix with each other, and so as to form a basically a hybrid orbitals. So S, Px, Py, Pz, and this is dxy. Now this will be involved in the formation of basically we could say like hybrid orbitals, and the structure of that would be basically in this way. That is, in that basically three hybrid orbitals that we'll get will be in a planar way. So they are present in the planar. So therefore, this is what I am talking about after mixing or recasting. So this is the thing that we have got. That is, this orbital that I am going to talk about is basically sp3d hybrid orbital. So this everyone is sp3 hybrid orbitals, but we have mentioned only three. Where is the rest of the two? So the rest of the two, that is what I want to mention over here as this one. So this is a structure that I'm going to talk about. And let me give an example in this case, that is this blue one that I have mentioned over here. Even this is sp3d hybridized orbital. So this blue one, they are present in the plane. While talking about that is this sp3d, this even it is an hybrid orbital. So they are present above the plane, and one of the orbital is present below the plane. So basically this green one is basically intersecting this planar, which consists of basically which is making a triangle shape, as you can see over here. This is making a triangle shape. So the triangle shape will have, obviously, where it is symmetrical, it will have an angle of 120 degree. So that is what I am talking it earlier. That is, it is 120 degree. While talking about the sp3d orbital, this green one, this is actually making a perpendicular. That is an angle, and that is the reason that the angle will be 90 degrees. So suppose that is what I am going to talk about. So therefore, the angle on this plane, it will be 90 degree. So these are the hybrid orbitals that I am talking about. So this is something of phosphorus. So now, so these are phosphorus that I was talking about, that is hybrid orbitals of phosphorus, and obviously the atomic orbitals of the same phosphorus, it will be involved so as to form this kind of structure. And now let us come back to the main thing. And the main thing is that I want to talk about, there are 5 actually chlorine atoms that are going to involve with that of the phosphorus one. And each chlorine atom is basically, if I'm talking about the chlorine, so chlorine has an electronic configuration that I could write it as basically 1s2, 2s2, 2p6, 3s2, and 3p5. So if I discuss about the that is orbital, so this is the s orbital, while these are the p orbitals, that is I'm talking about, that is the outermost shell, and this consists of basically 2 electrons, as you would see over here, and this consists of 5 electrons. So according to the Hund's principle, also we could follow in that way, and 1, 2, 3, 4, 5. So this is Hund's rule that we have followed. But as we know, that is unpaired electrons are being responsible for forming a bond. So in this case, basically this pz orbital of the chlorine is very much responsible so that it could form bond with that of the phosphorus. And talking about the pz orbital, so even I could get the shape of it, and that is basically it would be on z-axis. Suppose if this is what we have, like x-axis, y-axis, and this middle one, suppose it is z-axis. So therefore, this is somewhat I am talking about. This is the shape of pz orbital of chlorine. So now each pz orbital of the chlorine that would be involved in here so as to form bond with the phosphorus, and this is what I'm going to represent it over here in a way that is, suppose if this is the sp3 hybrid orbital of phosphorus, so now it will be involved with that of pz orbital of chlorine. So now another chlorine which will also have the same electronic configuration and same that is pz orbitals, that is basically unpaired. So now that consists of unpaired electrons. So that is what even that will be involved over here. And here also. Similarly here also. And here. So these are the that is I'm talking about chlorine atoms, and now I want to discuss about that. What would be the electrons combination? Obviously, phosphorus consists of 1 electron in its each hybrid orbital. So that is what I am mentioning it in a red one. So That is what we have got to know. And again, chlorine is the one which consists of at least one electron in its orbital, that is pz orbital. So even they will combine with in this way. So therefore here the valency is being maintained, and that is how the bond will be formed. So this is a structure that we have got to know. But I cannot draw it in a 3D diagram, so I hope you understand it, that what I'm drawing over here. And now let us come back to the same thing, that what would be the exactly geometry of this thing. So for that, let me give you a analysis. So let me give you a shape that how does it looks like. So suppose if I'm considering about phosphorus, so phosphorus will be in the middle. Meanwhile, there will be chlorine atom that would be attached over here. So let me explain it with the black one. Here also there will be chlorine, and here also there will be chlorine. So this three chlorines, they are present in the same plane. They are present in the same plane, but are evenly distributed in such a manner that the bond angle of this one basically is 120 degree, and for everyone it is 120 degree over here. And talking about the rest of the two, that is chlorine atoms, actually they are perpendicular to the plane, and this is what the chlorine is, or phosphorus chloride. If you are talking about, or this is what the structure is. But now let us understand that how the shape would be look like. So if I suppose if I join this planar one, so this one it looks like a triangle, while the above one is present, that is above the axis, above the plane and below the plane. And if I join it, I could see that while joining this all, the above structure is looking like a pyramid, while the below structure is also looking like a pyramid. So therefore, this kind of structure that we have got because of the sp3 hybridization is basically, it is known as trigonal bipyramidal. So this is actually the shape of the phosphorus pentachloride, the one which is following sp3d hybridization. And I'm missing something, and that is basically the angle between the chlorine which is present in above the plane and off the plane, that is, it is basically 90 degree. So this is what I want to talk about. So that it was one of the most easiest one, and because of what we have understood the hybridization. And that's it. That is what I want to talk about. So thank you friends for watching this video. I hope you have understood this video very clearly, and you have cleared your doubts. And I hope you'll share this video with friends, and just don't forget to subscribe to Ekeeda channel. Thank you so much.